friends, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss narrowband noise. What is narrowband noise and what are the components in this narrowband noise or discussed in this video. Okay, so first, what is a narrowband noise? In most communication systems, we are often dealing with bandpass filtering of signals. Wideband noise will be shaped into band-limited noise if the bandwidth of the band-limited noise is relatively small compared to the carrier frequency. We refer to this as narrowband noise. Or you can say the noise process appearing at the output of such filter is called narrowband noise. That means here we are taking one filter, we are giving this W of t at the input of this filter and this wideband noise which is going to process it and appears at the output, we can call as N of t. This N of t is the narrowband noise. Okay. Now for this N of t, what are the components having? There is in phase and quadrature. So these two components are having in this narrowband noise. So we are going to see that in phase component and out phase component. Okay. So let h of f denote the transfer function of the filter. Accordingly, we may express the power spectral density Sn of f of the noise N of t in terms of h of f as follows. That is Sn of f which is equal to mod square h of f. That is the filter response or the transfer function of the filter. So this is the noise spectral density, power spectral density of that noise N of t. So this is Sn of f. Sn of f. The noise spectral density and frequency domain of this narrowband noise we can see. Here Fc is the carrier frequency and B is the bandwidth of that message signal. So here we can see the frequency spectrum of this narrowband noise. Now let us solve this, find the in phase and quadrature components of that noise, narrowband noise. So we may represent the narrowband noise N of t in terms of its in phase and quadrature components. Let n plus of t and n tilde of t denote the pre-envelope and complex envelope of the narrowband noise N of t. Now what is the pre-envelope and how can you represent this pre-envelope? So n plus of t is the pre-envelope which is equal to N of t plus j n cap of t. So n plus of t is the pre-envelope. So how can you represent this pre-envelope in terms of N of t, narrowband noise, and n cap of t, that is a Hilbert transform of N of t. So there is 90 degrees out of phase for that narrowband noise, that n cap of t. And again, we are going to represent complex envelope of the narrowband noise, that is n tilde of t, which is equal to n plus of t into exponential minus j 2 pi fct. So this is our third equation. Now we are going to find, for this we are going to substitute n plus of t in the third equation. Okay, So that is n tilde of t. What is n tilde of t? That is a complex envelope of the narrowband noise, which is equal to n of t plus j n cap of t into exponential minus j 2 pi f c t. Now we are going to expand this exponential minus j 2 pi f c t. So it is in the form of exponential minus j theta, that is cos theta minus j sin theta. So similarly, we're going to substitute this one. Okay, that is n of t plus j n cap of t into cos 2 pi f c t minus j sin 2 pi f c t. So we are going to multiply this cos term with the both n of t and n cap of t. So which is equal to n of t cos 2 pi f c t plus j n cap of t into cos 2 pi f c t minus j n of t into sin 2 pi f c t minus, here we are having j n cap of t, and again we are going to multiply minus j. So the product of j terms gives j square minus 1. So already we are having minus sign, so minus of minus, it is plus n cap of t into sin 2 pi f c t. So here we are going to take common of this real terms and this j terms. So in the below equation, it is given n of t cos 2 pi f c t plus n cap of t sin 2 pi f c t plus again taking the j term common. So n cap of t cos 2 pi f c t minus n of t sin 2 pi f c t. Let nc of t, which is equal to n of t cos 2 pi f c t plus n cap of t sin 2 pi f c t. That is our fourth equation. That is in n tilde of t, which is equal to n of t, the first term, the first real parts were taken as nc of t. And again, in the z term, we can take it as ns of t. We represent the j terms as ns of t, which is equal to n cap of t into cos 2 pi f c t minus n of t sin 2 pi f c t, where nc of t and ns of t are the in-phase and quadrature components of the narrowband noise. So we are going to find those nc of t and ns of t terms. Therefore, n tilde of t, which is equal to nc of t plus j ns of t. So we get the desired mechanical form of representing the narrowband noise n of t by eliminating n cap of t from equation 4 and equation 5. So what is n cap of t? There is a Hilbert transform of n of t. So we are going to eliminate this n cap of t from equation 4 and 5. For this elimination, we are going to multiply equation 4 with cos 2 pi f c t, and again equation 5 with sin 2 pi f c t. Okay, so we are going to do that cos 2 pi f c t, which is multiplied with equation 4. Okay, so here our fourth equation is nc of t, which is equal to n of t cos 2 pi f c t plus n cap of t into sin 2 pi f c t. So we are going to multiply this with the cos 2 pi f c t term. So here I am writing equation 4, NC of t, which is equal to n of t cos 2 pi fct plus n cap of t sin 2 pi fct. It is n cap of t sin 2 pi fct. So this equation, which is going to multiply with cos 2 pi fct, and again we are going to multiply sin 2 pi fct with equation 5. So again go for the equation 5. So what is equation 5? That is ns of t, which is equal to n cap of t cos 2 pi fct minus n of t sin 2 pi fct. So this ns of t, which is equal to n cap of t into cos 2 pi fct, that is cos 2 pi fct minus n of t into sin 2 pi fct. So this whole equation, which is going to multiply with this sin 2 pi fct. Okay, so here we are going to multiply these two. So in the first one, we're getting nc of t into cos 2 pi fct, which is equal to n of t into, here cos term is there, and again we multiply with cos term. So cos theta into cos theta getting cos square theta. So there is cos square 2 pi fct plus n cap of t into sin 2 pi fct, which is multiplied with cos 2 pi fct. And again the fifth equation, what is n s of t into sin 2 pi fct, which is equal to n cap of t into cos 2 pi fct into sin 2 pi fct, and again minus n of t, again you are getting sin term, which is multiplied with again sin term. So sin square 2 pi fct. So these equations you can name as 6, 7 and 8. So we are going to subtract from those two equations to get our required. Okay, so we are going to subtract equation 8 from equation 7. So this we can take it as 8th one, and this we're going to subtract all this, you get minus, and this minus of minus plus. So getting n of t, nc of t cos 2 pi fct minus ns of t sin 2 pi fct. So that is ns of t, nc of t into cos 2 pi fct minus ns of t into sin 2 pi fct, which is equal to, here n cap of t sin 2 pi fct, which is going to, so try to get all these terms, that is and again n of t, which is going to multiply to get sin term. So finally we are getting n of t, which is equal to nc of t cos 2 pi fct minus ns of t into sin 2 pi fct. So this term, which is equal to n of t. So you get this n of t is nc of t cos 2 pi fct minus ns of t into sin 2 pi fct. Okay. So these are the in-phase and quadrature components of the narrowband noise. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.